Okay, this is our chapter 5 HL review. Question number 1. Part A of question 1 asks us to differentiate f of x. When f of x equals arcsine x, which is the inverse of sine x, plus 2 times the root of 1 minus x squared, for x equals the entire domain in between -1 and 1. So to differentiate f of x, we need to find derivative of f of x, which is f prime x. So the derivative of arcsine x is just the derivative of inverse of sine x, which is 1 over root 1 minus x squared. And then we multiply that with the derivative of x, which is just 1. Now we add that to the derivative of 2 root 1 minus x squared. And 1 minus x squared can be written again as 1 minus x squared to the 1/2 power. So the derivative of that the 2 root portion first is just 2 times 1/2 root of 1 minus x squared to -1/2 power. And then we multiply that with the derivative of 1 minus x squared, which is just -2x. So we get that f prime x equals 1 over root 1 minus x squared plus 2 times half times 1 minus x squared to the -1/2 power times -2x. So when we simplify that, we get 1 minus root 1 minus x squared plus 2 times 1/2, which is just 1, times 1 minus x squared to the -1/2 power. So that puts us, the negative portion puts us in the denominator, and the 1/2 puts us in the square root. So 1 minus x squared to the -1/2 power is just 1 over square root of 1 minus x squared. And you multiply that with -2x. So we have 1 plus, since this is the common denominator, 1 minus x squared and the root of all that. So we have 1 plus -2x over root 1 minus x squared, which simplified gets us 1 minus 2x over the root of 1 minus x squared. Now we're going to scroll down to the second part. Part B. Find the coordinates of the point on the graph of y equals f of x, ln. Find the coordinates of the point on the graph of y equals f of x in the domain between -1 and 1, where the gradient of the tangent to the curve is 0. So when the tangent to the curve is 0, that means the derivative is equals to 0. All right, the tangent of the curve is the derivative, or the gradient of the tangent to the curve is the derivative. So we want to find which point is the maximum. Well, we just got that the derivative equals 1 minus 2x over the square root of 1 minus x squared. Now, if we set that equal to 0, we get that 1 minus 2x equals 0, and 2x equals 1, therefore x equals 1/2. And we're going to plug that into our original function, f of 1/2. Our original function was, let me see, arcsine x. So arcsine 1/2 plus 2 to the root of, times the root of 1 plus x squared, so 1/2 squared. Okay, so arcsine 1/2, it just means inverse of 1/2, right? Which means that SOHCAHTOA, opposite of our hypotenuse, equals 1/2 of whatever angle, and we're trying to find that angle. Okay, if we plug that into the calculator, we get arcsine 1/2 equals to pi over 6, or 1/6 times pi.
Hey guys at school.
plus 2 times the root of 1 plus 1/2 squared. Well, 1/2 squared is 1/4. So that equals pi over 6 plus 2 to the root of 1 plus 1/4. That's 4/4 plus 1/4. That gives us 5/4. That gives us pi over 6 plus 2 over 2, this is root 5, equals pi over 6 plus root 5. Did I get that correct? Oh, my bad. I got the original equation wrong. So this is supposed to be a minus sign. Whoops. Well, if this is a minus sign, then it's just 4/4 minus 1/4. That's 3/4. We get root 3/2. And then our final answer is pi over 6 plus root 3, which is around, what is it, 2.26. So our final coordinates with x equals 1/2 and y being 2.26.